Hi guys, in this video we are going to learn about the topic of stoichiometry. Stoichiometry is the science of measurement. So in chemistry, when you perform a chemical reaction, you don't just mix chemicals in random amounts because A, that would be wasteful, and B, you want to make sure that you make the correct amount of product that you wanted. And so in order to figure all of that out, we have to learn the topic of stoichiometry. All right, to make it a little easier, we are going to split the topic of stoichiometry in three parts. Part one, we will learn how to convert mole to mole. Part two will be mole to gram, and part three will be gram to gram conversion. Now, as I take an example, what I mean by these three statements will be a lot more clear. But before I move on, there's one thing that we have to make sure, and that is that we always start with a balanced equation. Okay, that is why we learned, first of all, how to set up a equation, and then we learned how to balance it. So before you try to do any of these problems, make sure you know how to balance an equation. And if you don't, then you make sure that you get help and learn that first. So let us begin with a very simple, easy to understand equation, and that is the reaction that gives us water. Water is formed when hydrogen gas, which is H2, reacts with oxygen gas, which is O2, to make H2O. It should be pretty obvious that at this point you have two atoms of oxygen on the left side and only one atom of oxygen on the right. And so we must put a 2 over here, and that allows us to balance the O's. So you have two oxygens now and two oxygens. That, however, messed up your hydrogen atoms. And to fix that, we're going to put a 2 over here. Now, once you have balanced this equation, what does that really mean? It means that 2 moles of hydrogen gas are required to make 2 moles of water. In other words, the ratio of H2 to H2O is equal to 1 to 1. I hope that made sense. Because 2 moles of hydrogen give 2 moles of water, 1 mole of hydrogen should give 1 mole of water. On the other hand, the mole ratio of oxygen gas is 1 mole of oxygen gas is required to make 2 moles of water. So O2 is to H2O is a 1 to 2 ratio. And so that is the part that we need to understand when we are balancing equations. We balance the equation to find out the mole ratio. The mole ratio of hydrogen gas to water is 1 to 1. The mole ratio of oxygen gas to water is 1 to 2. Without this mole ratio, none of the stoichiometry is possible, which is why it is super important that you know how to correctly balance equation and make sure that you know what the coefficients stand for. Let's start another equation. This time around, I've already balanced the equation for you. So the mole ratio of sodium to sodium hydroxide is 2 to 2, or simplified as 1 to 1. The mole ratio of sodium and hydrogen is 2 to 1. The mole ratio of water to sodium hydroxide is 1 to 1. The mole ratio of water to hydrogen gas is 2 to 1. So what I want you to do is every time you balance an equation, you should be able to first figure out, do I know the mole ratios of all the elements? Okay, so I'm going to pause the video and I want you to write down all the mole ratios. And so once you find all the ratios, these are the ratios you should have found. This is a 1-to-1 ratio. This is a 2-to-1 ratio. This is a 1-to-1 ratio. This is a 2-to-1 ratio. This is a 1-to-1. And this is a 2-to-1 ratio. Now, what do we do with these ratios? Say, for example, I have 3.5 moles of sodium. How many moles of H2 do I expect? I know that from the balanced equation, the ratio of sodium to H2 is 2-to-1. Using that, what I can do is write 3.5 moles of sodium and multiply it by 1 mole of H2 and 2 moles of sodium. It is important to remember that because sodium is the given amount, then it has to be on the bottom of the conversion factor. So instead of a 2-to-1 ratio, we have a 1-to-2 ratio. This problem could also be asked the other way around. We could say that if I have 3.5 moles of hydrogen gas, then how many moles of sodium would we need? So that's a question that you could try to answer on your own. And at this point, all you need to do is just simple math. 3.5 divided by 2 should give you 1.75 moles of hydrogen gas. What does this answer mean? It means that if you start off with 3.5 moles of sodium, you will end up with 1.75 moles of hydrogen gas. And so this concludes the first part of the three-part video lecture series. In the next video, we will learn how to convert grams of the reactants to moles of the products, or if moles of the reactants are given, how do you find the grams of the product? All right, so I'll see you in the next video.